Hi friends, my name is Maruti and I am the co-founder of Krakow. In this video, we'll be looking at 10 solved questions from time, speed and distance for CAT. This is a very important topic for quant. In general, every year out of 34 questions in quant, you will be asked 4 to 5 questions every single year. And the concepts are very simple. So once you understand the concepts, it is quite possible that you will be able to answer all the questions from this topic. You just have to ensure that you're not making any silly mistakes. So try to read the question properly, try to understand the information that is given in the question and try to avoid any silly mistakes either during calculation or about how you have understood the question. If you avoid silly mistakes, there is a very good chance that you will get all the questions correctly. So in this video, we'll first display the question and then we'll explain the solution in a video. So when you look at the question, try to pause the video and try to solve it on your own. If you're not able to solve it, then go ahead and look at the video solution. Finally, we want to tell you that Krakow offers a lot of material for CAT for free on our website. We are providing 3 mocks for CAT which are in the latest pattern with detailed solutions. So you should check them out. The link for it is given in the description of this video. Similarly, if you're looking at any of the previous papers, either for CAT or XAT or IFT or any of the big MBA exams, for example, like SNAP or MAT, all of them, all the previous papers, you can download the PDFs. All of them are available on our website and the link for the same is provided in the description of this video. Finally, this year we have started something which many students are finding extremely useful. Every day, thousands of students are taking this. This is called the daily target. So every day we are providing one LRDI set, one reading comprehension set and 5 questions per quant from the same topic along with video solutions. This is completely free for the first 24 hours. So whenever a new test has been released, if you go to our website and try to solve it, you can take it completely for free. So use this. This we know for sure is going to help your preparation for CAT. Again, the link for daily target is given in the video description below. If you like this video, if you find our channel useful, if you find our video useful, please share it with your friends. Please share it amongst your other students. Please share it in WhatsApp groups. This is very important for us and we really appreciate if you can share it with as many people as you can. In this question, it has been given that there was a work that needed to be done and 30 men were hired to do it. They were also given a fixed time to complete the job. After 40% of the time had elapsed, they could finish only 1/3 of the work. Now, how many more men should be hired to finish the job in 2/3 of the original time? Now, let us assume that the required time in which the job had to be finished is 30 days. Why are we assuming 30 days? We are assuming it to be 30 days because a lot of this seem to have 1/3 and 2/3 in it. So, some good multiple of 3 would be a good start. So, assume that the initial time required was say 30 days. In 30 days, after 40% of the time elapsed, that is 40% of 30 days is 12 days. So after 12 days were done, they could finish only 1/3 of the work. So 30 men in 12 days could finish 1/3 of the work. So 30 men would finish the entire work in 36 days. So one man would finish the entire work in 36 into 30 days. This is basically, now we have a relationship between the total work that is there and how much work a man can do in one day. Now, what are we required to find out? We are required to find out how many more men should be hired to finish the job in 2/3 of the original time. The original time is 30 days. So 2/3 of the original time is 20 days. So 20 days, of this 20 days, already 12 days have elapsed. So there are 8 days left and the amount of work that needs to be done is 2/3. Now assume that the work units, because we know that one man has to do 36 into 30 days, assume that the total work that has to be done is 1080 man days. This is the total work that needs to be done. So 2/3 of that work is 2/3 into 1080. This comes to 720 man days is what is left of the work. This should be finished in 8 days. So the number of men required to finish this job, required to finish the remaining job would be 720 by 8, which is equal to 90 men. Of this 90 men, we already have 30 men. So the additional men, that is how many more men that should be hired, is 90 minus 30, which is equal to 60 men. This is the additional number of men that we need to hire to finish the job in 2/3 of the original time. In this question, it has been given that there are 3 people, A, B and C. They participate in a race. In a 1500 meter race, we are given that A beats B by 300 meters. We are also given that B beats C by 2.5 minutes in the same race. We are also given that A and C participate in another 3 kilometer race in which A beats C by 6 minutes and 40 seconds. We are asked to find out the speeds of A and C. In these kind of questions, if you can get the ratio of the speeds of A, B and C, you are done. So in one of the equations, we are given the ratio of their distances that they have traveled here, say 300 meters. And in the other one, we are given some sort of a relationship between the times that they have taken to travel, which is 2.5 minutes and 6 minutes and 40 seconds. So to make things simpler, let us assume that the speeds of A, B and C are small a, small b and small c. Now let us try to put down all the information that we know. We have been given 3 equations and 3 unknowns. So let us put them out in the form of an equation, find the value of A, B and C, and then we are done. We are told that A beats B by 300 meters in a 1.5 kilometer race. So when A travels 1500 meters, B travels 1200 meters. This is A and B. So we are given basically that A by B is equal to 1500 by 1200, which is equal to 5 by 4. This is the first equation. In the second equation, we are told that B beats C by 2.5 minutes in the same race. So 1500 by B, this is the time taken by B, and 1500 by C, this is the time taken by C. Now C takes more time, so this equals 2.5 minutes is equal to 150 seconds. This is the second equation. The third equation, we are given the relationship between the speed of A and C in a 3 kilometer race. It is mentioned that A takes 3000 by A seconds for the 3 kilometer race, and C takes 3000 by C. C takes more time, so this equals 6 minutes and 40 seconds is 400 seconds. Now we can solve these two, the second equation and the third equation. We can just simplify the third equation by dividing everything by 2, so that it makes it easier to eliminate C. We already have a relationship between A and B, so let us try to eliminate C. The third equation will transform to minus 1500 by A plus 1500 by C is equal to 200. If we subtract this equation, if we subtract the second equation from the fourth equation, we get is equal to 50, 1500 by B minus 1500 by A is equal to 50. We know that B is equal to 4 by 5 of A from the earlier equation. So this becomes, if we actually divide this by 50, we get 30 by B minus 30 by A is equal to 1. We are dividing the entire equation by 50. We also know that B is equal to 4 by 5 of A, or 30 by B is equal to 30 into 5 by 4A. Now 30 by B minus 30 of A, 30 by A is equal to 1. So 4A is equal to 150 minus 120, which is equal to 30, or A is equal to 7.5 meter per second. B is equal to 4 by 5 into A, which equals 6 meter per second. Now you can substitute the value of A in anyone in the equation C to find out that C is equal to 3.75 meter per second. We have just substituted the value of A in this equation. We need to find out the sum of the speeds of A and C. So A and C will become 7.5 plus 3.75, which is equal to 11.25 meter per second. This is a simple question where you have 3 equations and 3 unknowns. You can just solve them to find out the answer. In this question, it has been given that there is a train. It is going from P to Q. After it travels for 1 hour, it suffers some sort of a technical fault, because of which it is stopped for 2 hours. And after it resumes its journey, its speed is reduced to 3/4 of its original speed, and it reaches its destination 2 hours and 45 minutes late. It is also given that had the fall taken place 72 kilometers later, it would have reached only 2 hours and 27 minutes late. We are required to find the distance between P and Q. Now, to start off with, let us assume that the normal speed of the train is V, and let us assume that the normal time it takes to reach the destination is equal to T. Now, we are given that, so the total distance is V into T. This is what we are required to calculate. In the first step, we are given that, this is P and Q. The train initially travels for V kilometers without any hitch. Then it stops for 2 hours here, and the rest of the journey it completes 3/4 hours extra than what it normally takes. So if we represent it using an equation, we would know that the total distance traveled is the same. So the total distance is Vt is equal to V plus, normally this would have taken T minus 1 hours, because 1 hour is already taken, but now it is taking 3/4 extra. So 3/4 into V into T minus 1 plus 3/4. If we solve this, we can get an equation in T, because we can cancel off V. T is equal to 1 plus 3/4 into T minus 1/4, or T is equal to 3/4T plus 1 minus 3/16, or T/4 is equal to 13/16, or T is equal to 13/4 hours. So in this case, we have found out the total time that is taken, which is 13/4 hours. Now we need to calculate just the velocity, that is the normal velocity of the train, normal speed of the train, to find out the answer. So to do this, let us use the second piece of information that is given. So here the train stops after 1 hour of its journey, but if it had traveled 72 kilometers further at its normal speed, it would have reached the destination in 2 hours and 27 minutes. So if you compare what has actually happened with this case, what has actually happened was, it has traveled 1 hour at 72 kilometers at its normal pace, and the remaining journey, so P and Q, what has happened was, it has traveled V kilometers at its normal speed, and the rest of the journey at a reduced speed. But if it had traveled V plus 72 kilometers at the original speed at a faster rate, and it would have traveled 72 kilometers at a lesser speed, then it would have arrived 18 minutes early, because normally it had taken 2 hours and 45 minutes. But if it had traveled 72 kilometers further at a faster pace, it would have reached in 18 minutes earlier. If you represent it using an equation, you would get it that the time that had actually taken was 72 by 3/4V, minus, if it had traveled those 72 kilometers at a faster pace, this is equal to 18 minutes by 60. This is the only difference in the hypothetical situation and the actual situation that has happened. If you solve this equation, you will get the value of V. Let us try to do that. So this will be 4 by 3/4V minus 4 by V is equal to 1 by 60. Or this is 16 by 3 minus 4 by 3. This is 4 by 3V is equal to 1 by 60, or V is equal to 80 kilometers per hour. So we know V and we know T. Therefore, the total distance between P and Q is just V into T. which is 80 into 13 by 4, which is equal to 260 kilometers. In this question, we have found out the value of the time taken using the first equation that has been given, and we found out the speed of the train using the second equation, which says that if it had traveled 72 kilometers further, it would have reached 18 minutes before. And we get the answer, that is the total distance, by multiplying the two of them.
The secret to crack CAT is taking a lot of marks. We at Krakow give all the previous year's CAT, XAT and IFT papers in the actual exam format. Also, if you just Google Krakow free CAT mark, you can find 3 free CAT marks in the latest exam pattern. You can take them and get detailed analysis.
In this question, there is a thief. He is running towards an airport which is 100 kilometers away at the speed of 10 kilometers per hour. So here is the thief and he is running towards the airport. Now police are at a distance of 600 kilometers. This is the police. They are 600 kilometers away from the airport. So this is 100 and this is 600. This is the thief T and this is the police P. They are chasing in a van at 120 kilometers per hour. So this is 120 kilometers per hour. And the thief is running at 10 kilometers per hour. After 2 hours, the policeman got damaged and the speed was reduced to 90 kilometers per hour. So in these 2 hours, the police would have covered 240 kilometers. So for the police, at the end of 2 hours, the distance remaining is 360 kilometers. And from now on, they can travel only at 90 kilometers per hour. At that moment, the thief also realized that the cops were chasing him. So in these 2 hours, the thief would have covered 20 kilometers and he is 80 kilometers away from the airport. And this is 20. What is the minimum speed that the thief should run such that he escapes the cops? So here for the police to reach airport, the time it is going to take them is, there is 360 kilometers left and they are going at 90 kilometers per hour, so 4 hours. So the thief has to reach the airport before 4 hours and the distance that he has to cover is 80 kilometers. So the minimum speed at which the thief has to run will be 80 by 4, which is equal to 20 kilometers per hour. So he has to run at slightly more than 20 kilometers per hour to reach the airport faster. In this question, it has been given that there is a tank and it has 3 pipes A, B and C. The flow rates of A, B and C are in the ratio 1:2:3. Initially, the tank is empty and all 3 pipes are opened. Now pipe C is shut off after the tank was 1/3 full. After that, pipe B was shut off after the tank was half full. So for the last half tank, only pipe A filled it. And this process took a total of 110 minutes. We are required to find out the time taken to fill the tank if only A and B are used. To solve this, let us assume that the flow rates of A, B and C are A, 2A and 3A. This will just help us make the calculations easier. And let us assume that the total volume of the tank is V. Now for the first 1/3 of the tank, the total flow rate is, because all 3 of them are open, it is A plus 2A plus 3A. So it is 6A. This is for the first 1/3. That is V by 3 of the tank is filled. Now from V by 3 to V by 2, that is V by 2 minus V by 3, the flow rate is A plus 2A, that is 3A. And for the last V by 2, the flow rate is A. Therefore, the total time taken will equal V by 3 by 6A. This is the first 1/3. After that, for V by 6, that is the second part, plus V by 6 by 3A. And for the third part, this one, V by 2 by A. This is the total time taken and this equals 110. Now if you simplify this, you get V by 18A plus V by 18A plus V by 2A is equal to 110. The common denominator, you can make it as 18A because that's the LCM, this will equal V plus 9V is equal to 1110, or 11V by 18A is equal to 1110. You can cross multiply and you can find that V by A is equal to 180. Now once you get that, we are required to find out the time taken if only pipes A and B are used. Pipe A has A and pipe B has 2A. So the total flow rate will be 3A and the total time taken will be V by 3A. We know that V by A is equal to 180. Therefore, V by 3A will be 180 by 3, which is equal to 60 minutes. Therefore, the answer in this case is 60 minutes. Okay, in this question it is given that on a straight road there are 2 points P and Q. Virat and Rohit are two persons who are standing at points P and Q respectively. So suppose this is P and this is Q. Virat is standing here and Rohit is standing here. They start running towards each other at constant speed. So Virat is going towards Rohit and Rohit is going towards Virat. As soon as they reach the opposite point, they immediately turn back and run towards their respective point. So they keep going like this. Virat keeps going towards Q, and after reaching Q, he will come back towards P. The same process continues till one of them has completed 10 trips. One trip is going to the opposite point and returning back. Virat and Rohit meet for the first time 540 meters away from P. So the first time that they meet will be 540 meters away from P. So let the distance between P and Q be L. Therefore, Virat has run 540 meters and Rohit has run L minus 540 meters the first time that they meet. The second meeting takes place 600 meters away from Q. So the second time is when this is 600 meters and this is L minus 600. Find the distance in meters of their third meeting point from Q. So we need to find out where they meet for the third time. It is known that both the people never cross each other while traveling in the same direction. That is, they are always crossing each other whenever they are traveling in the opposite direction. So to start off, let us put a simple table. This is Virat, this is Rohit, and this is the total distance that both of them have traveled. The first time that they meet, Virat has traveled 540 meters. This is the total distance traveled by both of them before the first meeting. Virat has traveled 540 meters and Rohit has traveled this, which is L minus 540. Now if you include both of them, that is Virat plus Rohit, both of them together have covered L. That is, they have covered the distance between P and Q once. Now the second time that they meet, if you are looking at Virat, he will cover the entire distance L and then come back and meet Rohit here. So he has covered L plus 600. Similarly, if you are looking at Rohit, he also covers L and then he comes back and he meets Virat here. So he has covered L plus L minus 600. So this is 2L minus 600 is the distance travelled by Rohit. And the total distance travelled by both of them will be 3L. That is because the total distance travelled by them will be 3 rounds, which is actually equal to L plus 600 plus 2L minus 600. Now what we should consider is each of these ratios will remain the same. That is 540 by L plus 600 is equal to L minus 540 by 2L minus 600 is equal to L by 3L. That is because their speeds are constant. The distance that they travel the first time and the second time will be in the same proportion. So we can calculate, we can compare any of the two numbers, any of the two ratios to calculate the value of L. You can feel that comparing these two is the easiest to solve for L, because L by 3L is a constant which is 1 by 3. Therefore, if you look at it, 540 by L plus 600 is equal to 1 by 3. If you solve for it, 1620, which is equal to 540 into 3, is equal to L plus 600, or L is equal to 1020. Now we need to calculate the distance that the total distance that each of them have travelled. This is 540 L minus 540 will be 480, which is 1020 minus 540, and L is 1020. Similarly, the next time that they meet, the distance travelled by Virat will be L plus 600. This is the total distance that he has travelled, which is 1620. If you notice, 540 into 3 is 1620. Similarly, the distance that he would travel when they meet for the third time will be 540 into 5. 540 into 5 is 2700. So this is the total distance that Virat has travelled. Now this is 540. No, this is 1020. When they come back, this will be another 2040. So after 2040, he has again travelled some distance, but the total distance that he travelled is 2700. So this is 1020. He comes back again to P. This is another 1020. And finally, when he goes back here, he has covered 2700 minus 2040, which is equal to 660 meters. So he is 660 meters from P, and the distance that he is from Q, this will be 1020 minus 660, which is equal to 360 meters. So he meets Rohit for the third time when they are 360 meters from Q. To solve this question, we have just equated the ratio of the total distance travelled by them the first time and the second time, and we have calculated that the distance between P and Q is 1020 meters. Once we have calculated that the distance between P and Q is 1020 meters, we have calculated the total distance travelled by Virat before they meet for the third time. The total distance that they travelled before they meet for the third time will be 540, which is the distance he travelled for the first time, into 5, which is equal to 2700. Once you know 2700, you can calculate that they are 360 meters away from Q. In this question, it has been given that there is a work that has to be completed by X workers. On every second day, 2 workers drop, and on every third day, 1 worker joins. Now, on the 7th day, 17 workers are present. The time taken to finish this work in this way is 15 days. What would have been the time taken by X workers to complete the same work if no worker had dropped or joined? So if you look at it, on the first day, there are X workers. On the second day, there will be X minus 2 because 2 is an even number, and on every even number, 2 people are dropping. On the third day, it will be X minus 1 because 1 person would join on every multiple of 3. So again on the fourth day, 4 is even, so there will be 2 which will be decreased. So on the fourth day, there will be X minus 3 workers. On the fifth day, because 5 is not a multiple of either 2 or 3, there will be no change in the number of workers, so it will be X minus 3. On the sixth day, because 6 is a multiple of 2 and 3, first it will go down by 2, so it will become X minus 1, and then 1 worker will join, so it will become, it will be X minus 3 will be initially the case, 2 workers will leave because it is a multiple of 2, and then 1 worker will join. So if you look at it, it will be X minus 3 minus 2 is X minus 5, plus 1 is X minus 4. On the 7th day, because it is not a multiple of either 2 or 3, there will be no change in the number of workers. On the 8th day, it will be X minus 6 because again 8 is a multiple of 2. Similarly for 9, because it's a multiple of 3, there will be 1 worker who will join, so it will become X minus 5. For 10, it will be again decreased by 2 because it is a multiple of 2. For the 11th day, there will be no change because 11 is not a multiple of 2 or 3. For 12, it will be similar to 6. First 2 workers will leave and then 1 worker will join, so it will effectively go down by 1. So on the 12th day, it will become X minus 8. On the 13th day, there will be no change, it will be X minus 8. On the 14th day, it will go down by 2, so it will be X minus 10. And on the 15th day, it will go up by 1, so it will be X minus 9. Now what we are told is that on the 7th day, there are 17 workers present. On the 7th day, it is X minus 4. So this would mean that X minus 4 is equal to 17 or X is equal to 21. So there were 21 workers initially, and on the 7th day, there will be 17 who are remaining. Now if you assume that the amount of work done by one worker, work done by one worker in one day is equal to say 1 unit. We are using this to get an estimate of the total work that is done by the X workers in this 15 days. So if we keep calculating, on the first day there are 21 workers who are there, and on the second day, because it is X minus 2, only 19 workers remain. Similarly, on the third day there are 20 workers, on the fourth day it is 18, fifth day is 18, sixth is X minus 4, so it is 17, seventh day is also X minus 4, it is 17, on the 8th day it is X minus 6, so it is 15, 9th day is X minus 5, so 16, 10th day is X minus 7, so 14, 11th day is also 14, 12th is X minus 8, so 13, 13th day is also X minus 8, so 13, 14th day is X minus 10, so 11, and 15th is X minus 9, so 12. So these are the number of workers who are present on each of these days, and because we are assuming that the amount of work done by one worker in one day is 1 unit, the total work done is also equal to the same number. Using this, we can calculate the total work that needs to be done in these kind of units. So for that, we will have to just sum all of this. So 21 plus 19 is 40, 40 plus 20 is 60, 60 plus 18 plus 18, that is 60 plus 36 is 96, 96 plus 17, 17 is 34 is 130, 130 plus 31 is 161, 161 plus 28 is 189. Similarly, over here it is 13 plus 13 is 26, 26 plus 23, 26 plus 11 is 37, 37 plus 12 is 49. So if we sum 189 and 49, we will get 238. So the total amount of work that needs to be done is 238 units. Now if none of the workers left, there would have been 21 workers on each of this day. On all the days there would have been 21 workers, and they would be doing 21 units of work per day. And the total work that needs to be done is 238 units. So the time that it would have taken them would be 238 by 21. This will come to, this will come to roughly 11.3 unit, 11.3 days. This is the answer. In this question, it is given that there are two balls. One is of type 1 and the other is of type 2. The ball of type 1 bounces to a height of 2h by 3 when it is dropped from a height of h, and ball of type 2 bounces to a height of h by 2 when it is dropped from a height h. Two balls, that is one of type 1 and one of type 2, are dropped from 12 meters and 36 meters. Then what is the sum of the total distance that they travel after bouncing indefinitely? So if you look at type 1 ball here, and if you look at type 2, the ball of type 2 is 36 meters and this one has 12 meters. So initially if it is at a height h, then it will come to 2h by 3, then go down and then come to 2 by 3 of that, that is 4 by 9, and again go down and again continue doing it until it will finally fall down to 0. Now if you look at it, this is height h, which is the initial height from which it is dropped. Then it rises to a height of 2h by 3 and it again falls 2h by 3. Similarly, the next time it is going to rise up to a height of 4h by 9, which is 2 by 3 times 2h by 3, and again fall 4h by 9, and so on. So you can see that this is actually similar to a geometric progression, even though it is not exactly a geometric progression. So this will have h plus 2h by 3 plus 2h by 3 because it is done twice. It goes up once and it comes down again, plus 4h by 9 plus 4h by 9 plus dot dot dot. So if you look at, if you ignore the initial h, every other term is repeated twice and it is a geometric progression of ratio 2 by 3. So the sum of this will actually equal h plus 2 into 2h by 3 plus 4h by 9 plus 8h by 27 and so on. Now if there is a geometric progression where the ratio r, the modulus of the ratio if it is less than 1, that is it is a converging geometric progression, then the sum of all the terms of the geometric progression will equal a, which is the first term, by 1 minus r. This is valid only if the common ratio r lies between minus 1 and plus 1. If r is greater than 1 or less than minus 1, it will not be a converging geometric progression. So the terms will keep on expanding and tend to go towards infinity. So it will have no sum. Anyway, we will be using this formula to find out the sum. Now this is a geometric progression. The first term is 2h by 3 and the common ratio is 2 by 3. So the total sum will be h into h plus 2 into a, that is the first term is 2h by 3 by 1 minus 2 by 3, which is the common ratio. 1 minus 2 by 3 is 1 by 3. So we will just multiply the numerator and denominator by 3. So this will become h plus 4h, which is equal to 5h. In this case, h is 12 meters. So this will be 60 meters. So the total distance traveled by the ball of type 1 is 60 meters. If you are looking at the ball of type 2, it will have a similar direction. It will have a similar way in which it travels, but the numbers will change a little. So in this case, it will travel h once, which is the initial height from which it is docked. Then it is going to travel h by 2 while going up and h by 2 while coming down. Similarly, h by 4 while going up plus h by 4 while coming down, and so on. So this will also be similar. So it will be h plus 2 into h by 2 plus h by 4 plus h by 8 plus so on. This will equal h plus 2 into, this is also a geometric progression where the starting term is h by 2. This is the starting term and the common ratio is half. So this is 1 minus h by 2. So this will equal h plus 2h, which is equal to 3h. Now h in this case is 36 meters. So 3h will be 108 meters. So the total distance that both the balls travel together will be 60 plus 108, which is equal to 168 meters. In this question, we are given that there are 3 people, A, B and C. They can complete a task in 10 days while working together. A and B working together will take twice as much time as B and C working together to complete the same task. Now the contractor wants the job to be done in fewer number of days, and hence he hires 3 more persons, D, E and F, to do the job. It is given that D is twice as efficient as B, F is 4 times as efficient as C and E is as efficient as A. Then the job will get done in how many days? Clearly this involves efficiencies of all these 6 people. So let us assume that the efficiency of each one of them is small a, small b, small c, small d, small e and small f. Now let the total work that needs to be done be equal to 100 units. Let the total work that needs to be done be equal to 100 units. A, B and C, when they are working together, can complete the job in 10 days. So the number of units of work done by A plus B plus C in 1 day is equal to total work that is needed, that is 100 units, by the total number of days that they take, which is 10. So A plus B plus C is equal to 10 units. So the 3 of them do 10 units of work every day. It is also given that A and B, while working together, take twice as much time as taken by B and C working together. Therefore, the efficiency of A and B is half the efficiency of B and C. So A plus B is equal to half into B plus C, or 2A plus B is equal to C. Now if you combine the first equation and the second equation, we will try to get the values of B and C in terms of A. Similarly, all the values, that is D, F and A, E also will try to get in terms of A. Then we will combine A plus B plus C plus D plus E plus F, that is the total work done by all of them, and then see how to go forward from there. So if you look at the first and second equations, A plus B plus C is equal to 10, but C is equal to 2A plus B. So A plus B plus 2A plus B is equal to 10, or 3A plus 2B is equal to 10, or B is equal to 5 minus 1.5A. This is the third equation. Now we will substitute this in the second equation to get C in terms of A. C is equal to 2A plus B. but b is equal to 5 minus 1.5a. So this is equal to 2a plus 5 minus 1.5a. So c is equal to 5 plus 0.5a. This is the value of c. D is twice as efficient as b. So d is equal to 2b, which is equal to 10 minus 3a. E is as efficient as a. So E is equal to a, and F is 4 times as efficient as C. F is equal to 4C, which is equal to, this is the value of C, 20 plus 2a. Now when you are trying to calculate the total work done by the 6 people in one day, that is A plus B plus C plus D plus E plus F, we will express each one of them in terms of A as we have calculated before. So A is equal to A plus B is equal to 5 minus 1.5a. C is equal to 5 plus 0.5a. D is equal to 10 minus 3a. Plus E is equal to A, and F is equal to 20 minus 2a. So the total work done in one day by the 6 people is this sum. If you simplify this sum, this is equal to, if you just calculate the constant term first, it is 5 plus 5 plus 10 plus 20. So this is 40. Now if you are looking at the A terms, this is A plus A minus 1.5 is minus 0.5a, plus 0.5 is 0, minus 3a, plus a, this is 20 plus 2a actually, this is the value of f. So if you are looking at the A term again, this is a minus 1.5a plus 0.5a is 0. Similarly, minus 3a plus 2a is again equal to 0. So the A terms cancel each other, and the total work done by the 6 people in one day is equal to 40 units. Therefore, the number of days that the job takes to get completed is 100 units, which is the total work, by 40, which is the amount of work done by the 6 people in one day. So this equals 2.5 days. In this question, it is given that there are two persons, Rinesh and Rinsha. They are moving in the same direction around a circular track of radius 7 meters. So there is a circular track and both of them are moving in the same direction. The ratio of the speed of Rinesh to Rinsha is 7:1. How many times are they diametrically opposite to each other during one lap of Rinsha? So Rinsha is the one who is slower. So there is one concept that you should remember, that if there are two people who are running around a circular track, and if the ratios of their speed is A is to B, and if they are running in the same direction, then the number of points at which they meet is modulus of A minus B. Now A and B are considered to be prime to each other. They are supposed to be relatively prime to each other. So if say there are 3:2, then the number of points at which they meet is 1. If there are say 4:1, the number of points at which they meet is 3. Similarly, if they are running in the opposite directions with speeds A is to B, the number of points at which they meet will be modulus of A plus B. So if say their speeds are again 3:2, but they are running in opposite directions, they will meet each other in 5 places. Similarly, if their ratios of their speed is 4:1 and they are running in opposite directions, they will meet each other in 5 places. Now using the same concept here, the ratio of their speed is 7:1 and they are running in the same direction. Now so they will meet in 6 distinct points. How did we get this 6? Because 6 is modulus of 7 minus 1. So the 6 points will be, the first one will be the starting point, then there will be 5 other points, which all of which are equally placed from each other. Now both of them will start here, and by the time Rinsha finishes her first, before she moves from the first point to the second point, Rinesh is going to complete an entire circle and is going to come here. Now in this, and they'll meet each other at the same time at the second spot. But between this journey, there will come a point when Rinsha will be somewhere over here and Rinesh will be diametrically opposite her. So this will be the first point at which both of them will be diametrically opposite each other. Similarly, at the second point, both of them start at the same time, and by the time Rinsha covers the distance between the first point and the second point, Rinesh will again complete the entire circumference and meet her here. And within this point, within this time period, there will come a point, say over here, where Rinsha and Rinesh will be diametrically opposite each other. So this is the second point. Similarly, by the time Rinsha moves from the second to the third, there will come a point where both of them are diametrically opposite each other. Similarly, in the fourth and fifth, so at the end of the fifth point, both of them will be here. And by the time Rinsha goes from the fifth point to the original point, Rinesh will again complete another circle and meet her at the starting point, and there will come a point over here approximately where Rinsha will be here and Rinesh will be here. So there will again be a point where both of them are diametrically opposite each other. So the total number of points will be at which both of them are diametrically opposite each other will be 6 before Rinsha completes one whole lap. So the answer in this case is 6.